1, 2, 3, let's go!
Hey guys, it's me, Ashley the Math Tutor. Welcome back to my YouTube channel. Alright, let's get started with today's video. So in this unit, we are going to be talking about trigonometric integrals using substitution, or basically trig integrals with higher powers. So basically in this unit, we're going to work on integrals that look like this, like these basically. So we're going to work on integrals that look like this: sine x to the n power times cosine x to the n power dx. We're also going to work on the integral of tan x to the n power times secant x to the n power dx. Also, we're going to work on integrals that look like sine x to the n power dx, cosine x to the n power dx, tan x to the n power dx, and secant x to the n power dx. Also, all of the exponents, like all the powers, m and n and m and n and all of these, all the powers, they're going to be greater than or equal to 1. Usually greater than 1, but it could be equal to 1, but all the powers are going to be greater than or equal to 1. That's why I said higher powers and stuff. So for topic 1 of this unit, I'm going to be doing 3 videos on integrals that look like this: the integral of sine x to the n power times cosine x to the n power dx. Topic 2, I'm going to be doing 3 videos on integrals that look like this: the integral of tan x to the n power times secant x to the n power dx. And for topic 3, I'm going to do 2 videos on integrals that look like this, which are basically, they're basically the individual trigonometric integrals. So the integral of sine x to the n power dx, the integral of cosine x to the n power dx, the integral of tan x to the n power dx, and the integral of secant x to the n power dx. So like I said, for topic 1, we're going to do integrals that look like this: the integral of sine x to the n power times the integral of cosine x to the n power dx. I'm going to do 3 videos on this topic because there are 3 different scenarios for this type of integral. There are 3 scenarios. So there's a scenario where m, the exponent of the sine function, is odd, and n, the exponent of the cosine function, is even. There's also a scenario where m, the exponent for the sine function, is even, and n, the exponent for the cosine function, is odd. And there's also a scenario where m and n are both even, or m and n are both odd. So for topic 1, I'm going to make a video for each scenario. So yeah. In the previous video, I just did scenario 1 where m is odd and n is even. So now in this second video, I'm going to be doing scenario 2 where m is even and n is odd. So here are some important things to remember for this video. I'm going to be bringing up things called equation 1 and equation 2, and I'm going to be bringing up things called rule 1 and rule 2. I'm going to be referring to them as rule number 1, rule number 2, equation number 1, equation number 2. So you guys might want to write this stuff down. So for equation 1, this is a trigonometric identity. Sine x squared is equal to 1 minus cosine x squared. And then also for equation 2, that I'm going to be, for what I'm going to be referring to equation 2 as for this video, is this, another trigonometric identity, which is cosine x squared is equal to 1 minus sine x squared. And then here's a couple like algebraic rules that are really important for this topic as well. So x to the power of a plus b, if a plus b was a number, right, that would be equal to x to the power of a times x to the power of b. Also, x to the power of a times x to the power of b is equal to x to the power of a plus b. Now, for rule number 2, x to the power of a and this whole thing, all of this, to the power of b is equal to x to the power of a times b. And also, x to the power of a times b is equal to x to the power of a and all of this to the power of b. These are really important rules to remember. So I'm going to put them in the frame here. And then you guys can like pause the video to write them down and stuff. Let me just put it here and you guys can like pause to write it down because this is very important. This is what I'm going to be referring to as equation 1 and equation 2, rule 1 and rule 2. Okay, so before we continue, I'm going to do a little example of rule number 1 and rule number 2. So first off, I'm going to start off with rule number 1. Rule number 1. So let's say we were to do x to the 4th power times x to the 7th power. As you can see, these are two terms that are like have the same base, and then they're being multiplied by an exponent. For that, if it's two terms being multiplied with the same base being multiplied by each other, you can add the exponents. And also you multiply the coefficients, but here the coefficients are just 1 times 1, so that's going to be 1, so it'll just be still 1x, which is just x. So x to the 4th times x to the 7th, that's going to be x to the 4 plus 7, which is going to be equal to x to the 11th. Conversely, x to the 11th is also equal to x to the 4 plus 7 because x, oops, my bad. Let me rewrite that 4. X to the 11, and because 4 plus 7 is equal to 11, so x to the 11th power is equal to x to the 4 plus 7 power, which is also equal to x to the 4th times x to the 7th. Remember, we can, if it's an exponent like this, you can break it down into two numbers that it's equal to and also break it down this way. That's rule number 1. Now let me do an example of rule number 2. This is just algebra, but sometimes students I used to tutor, they used to forget this rule or get them confused. So I just want to like really lay it out for you guys. So for rule number 2, right? Say we were to have x to the 4th power and this whole term, all of this, to the 7th power. Here, if it's one term to a power and the whole, all of the term to the powers to another power, you multiply the exponents. So x to the 4th to the 7th power would be equal to x to the 4 times 7, which is just equal to x to the 28th. Also, x to the 28th power, since 4 times 7 is equal to 28, this can be broken down into x to the power of 4 times 7, since 4 times 7 is equal to 28. And then this 4 times 7, if it's times, it can be broken down into x to the 4th and all of that to the 7th power. If the exponents are timed, it can be broken down like this, to one term to that power and all of that to the power of all of this, basically. So it can be broken down like this. So yeah, here's an example of rule number 1 and number 2. If you guys wanted to pause real quick and write this down. It's just, you know, algebra, but it's really important to remember for this topic and stuff. Alright, so now let's do scenario 2 out of the 3 scenarios. Scenario 2 is when m is even and n is odd. So that means when the exponent for the sine function is even and the exponent for the cosine function is odd. We'll do this as an example. The integral of sine x to the 4th power times the integral of cosine x to the 5th power dx. So as we can see, 4 is the exponent of the sine function and it's even. And 5 is the exponent of the cosine function, and 5 is odd. Alright, so let's start with step 1. Alright, so for step 1, we're going to break off a power of cosine x from the cosine term. We're going to put it in the format of cosine x to the power of something times cosine x to the power of 1, which is just cosine x to the power of something times cosine x. Then we rewrite the integral. Okay. So, like I said, like I do in the other videos, the steps are going to be on the left side and the work shown is going to be on the right side. So, what do we have so far? So the integral we were given was sine x to the 4th power times cosine x to the 5th power dx. We're going to take this and we're going to break off a power from the cosine term and then put it into this format. So remember, like I said, with the rules and stuff like that, we can take this and break it into cosine x to the 4 plus 1, and from there we can take that term and break it down even further to get into this format. So let me show you what I mean. So cosine x to the 5th power is equal to cosine x to the 4 plus 1 power. So like I said, so using rule 1, we can take this 4 plus 1, this cosine x raised to the power of 4 plus 1, and we can break it down into cosine x to the 4th power times cosine x to the power of 1. And that equals, since anything to the power raised to the power of 1 is itself, we can just say it's cosine x to the 4th power times cosine x times cosine x. Because anything to raise to the power of 1 is just itself. So we can do it like this. So since we established that cosine x to the... Let me fix that x right there. Since we established that cosine x to the 5th power is equal to cosine x to the 4th times cosine of x, we can take this and we can replace this right here, cosine x to the 5th power, with this. So let's rewrite the integral, like it says here, to rewrite the integral. Oh, and tidbit, quick side note, this cosine x to the 4th times cosine x, it matches this format, which is exactly what we were trying to do. So now let's rewrite the integral. So now if we rewrite the integral and we replace this with this, we would get sine x to the 4th power times cosine x to the 4th power times cosine x dx. Alright, so that's all we have for step 1. So now let's go to step 2. Alright, so for step 2, what we're going to do is we're going to rewrite the cosine term. And when I say the cosine term, I mean the cosine term where the exponent does not equal 1. And we're going to rewrite it in the following format. Cosine x squared to the power of something. You can skip this step if the particular cosine term is already like this after you do step 1. And a little hint, 2 times the something should be equal to n minus 1. So the something that we get here, 2 times that something should be equal to n minus 1. So what do we have so far? What we have so far is sine x to the 4th power times cosine x to the 4th power times cosine x dx. The cosine term where the exponent does not equal 1 is this one. Because here the exponent is 1, but here the exponent does not equal 1. So we're going to take this and we're going to rewrite it into this format. So, remember how I said in rule number 2, before I even bring that up, let me write it here, cosine x to the 4th, right? So we have to take this and put this into the cosine x to the 2nd power to the power of something. Now, remember how I said in rule number 2, you can break down the 4 into this, right? So cosine x to the 4th is equal to cosine x to the power of 2 times 2. Because remember, 2 times 2 is equal to 4. So the cosine of x to the power of 2 times 2, if it's times, then what we can do is we can break it down like this. We can break it down like cosine x to the power of 2, and all of this raised to the power of 2. So this 2 right here, this is the something. So it goes here too. So the cosine x squared, all of this to the power of 2, this means that this something would be the 2 that goes here. So all you need to remember for this step is cosine x to the power of 2, all of this to the power of something, that something times your 2. That's basically, if you take the exponent of the cosine x function, the cosine x term where the exponent does not equal 1, if you take the exponent of that and you divide it by 2, that's what should be here. That's basically how that works. And then also for the hint, as we can see, let me put hint. For the hint, as we can see, 2 times the something should be equal to n minus 1. So as we can see, the something is 2. And from when we started, we can see n is the exponent of the cosine function, which is 5, right? So we have to do 2 times 2. Let's see if it's equal to 5 minus 1. It is, because 4 is equal to 4. And so that is correct. So I'm kind of running out of space, so I'm going to do it over here. Let's rewrite the integral using this format. And we're going to replace cosine. We're going to replace cosine x to the 4th power with cosine x squared to the power of 2. So we're going to just rewrite the integral. I'll put rewritten integral. Hopefully I have enough space. Okay, the integral of sine x to the 4th times cosine x squared, all of that to the power of 2, times cosine x dx. This is the rewritten integral. Sorry if you guys kind of can't see it. Sorry, I'm trying to, let me bring that up a little closer. That's what it looks like. Yeah, so sine x to the 4th times cosine x to the 2nd power, and all of that to the power of 2 times cosine x dx. That's the rewritten integral. All right, now let's go to step 3. All right, so for step 3, as we recall from equation 2, the trigonometric identity cosine x squared is equal to 1 minus sine x squared. So in the equation, we can rewrite the integral, and we can replace cosine x squared with 1 minus sine x squared because they equal the same thing. So let's see what we had before. What we had before was the integral of sine x to the 4th power times cosine x to the 2nd, and all of this to the 2nd power times cosine x dx. Now, like we said here, this trigonometric identity, cosine x squared is equal to 1 minus sine x squared. This 2 and the x are kind of touching. Let me kind of highlight that so you guys can see. So cosine x squared is equal to 1 minus sine x squared. So we're going to take this term right here and we're going to replace it with that. So if we were to rewrite the integral replacing cosine x squared with 1 minus sine x squared, we would get this. We'll get the integral of sine x to the 4th times 1 minus sine x squared, and all of that to the 2nd power times cosine x dx. All right, now let's go to step 4. Alrighty, so for step 4, we're going to rewrite the equation such that all of the sine terms are on the left side of the integral and all the cosine terms are on the right side of the integral. We can skip this step if it's like this already. So let's take what we have from step 3, which is sine x to the 4th times 1 minus sine x squared, and all of that squared times cosine x dx. So well, it's like this already, so we can just skip it because all of the sine terms, sine x to the 4th and 1 minus sine x squared to the 2nd, or also in addition to the 2nd, you could also say squared. So let me re-say that, sorry. So it's already like this because then we have the integral of 1 minus sine x to the 4th times 1 minus sine x squared, and all of that squared times cosine x. All of these sine terms are on the left side, and the cosine terms are on the right side. So it's pretty much just like this. Like we said, we want the sine terms on the left side, which they both are, and all of the cosine terms on the right side, which it is. So we can skip because it's like this already. So let me write that. Skip this step because it's already like this. All right, so now let's go to step numero 5. All right, so for step 5, we're going to substitute using u. We're going to use some u substitution here. We're going to make u equal sine x, and then we're going to take the derivative of u. We're going to take the derivative of u with respect to x, which is du dx. Then we're going to solve for du. So like we said, u equals sine x, right? So we're going to take the derivative du over dx. So du over dx equals the derivative of sine x, which is just cosine x. Now, next we have to solve for du. So to solve for du, we have to cross multiply, then get du by itself. So du over dx would be equal to cosine x over 1, because anything divided by 1 is itself. Then we can cross multiply, and then we can say du times 1 is equal to cosine x dx. And then since anything times 1 is itself, we can do du is equal to cosine x dx. All right, now let's go to step 6. So for step 6, we're going to rewrite the answer from step 4 in terms of u and du. So let's take what we had from step 4, which was the integral of sine x to the 4th times 1 minus sine x squared and all of that squared times cosine x dx. So, like we said before, let me put this in a different color. I don't know if the camera will see the color, but I'm putting this in red. U is equal to sine x, and then du over dx is equal to, oopsie. It's not supposed to be du over dx. We solve for du. It's supposed to be du. So du is equal to cosine x dx. Oh, and let me just put this little tidbit in step 6 real quick. Well, let me put my arm around this way. So just a quick little tidbit. To solve in terms of du, solve for cosine x dx. To solve in terms of du, solve for cosine x dx. If it's like this, that's fine. You can skip the step and just keep going. But if it's not already like this, if this was like a negative sign or something like that, then you would just solve for only cosine x dx. But since it's already like this, it kind of makes life easier. But if it wasn't, to solve for in terms of du, to put in terms of du, to rewrite basically is what I mean. To rewrite in terms of du, solve for cosine x dx. Now, like I said, it makes it kind of easier because it already is solved for cosine x dx. So u substitution with du will be, just very simple and stuff. But anyway, let's rewrite the answer. So we're going to take all of these terms, this term, this term, and this term, and rewrite it in terms of u and du. Okay, so let's start with the first term. The first term is sine x to the 4th power. Now, like we said, u is equal to sine x. So that means everywhere we see sine x, we put u instead. Let me put a box here to resemble sine x, and then put a 4th here because it was sine x to the 4th. But since we're substituting u for sine x, we'll just do u to the 4th. See what I mean? Because since it was sine x to the 4th and u is equal to sine x, to resemble sine x to the 4th, we instead do u to the 4th, because everywhere we see sine x, we're going to put u instead. In the same manner, let's do the second term. Oops, not the cosine. Oop, let me put some little whiteout on that. Sorry, y'all. I can't believe I'm doing whiteout in the middle of a video. That is so... Sorry, guys. I meant just this term for now, for this specific term. So the 1 minus sine x squared, and then this is, and then 1 minus sine x squared. So the 1 minus sine x squared, and all of that squared. So 1 minus sine x squared on all of that squared. This second term right here, we're going to take this and we're going to rewrite it in terms of u. So we have 1 minus sine x squared, and all of that squared So, like we said before, u is equal to sine x. So everywhere we see sine x, we're going to put u instead. So I'll put this box here to resemble sine x. And sine x here was squared. So what we would get is 1 minus u squared, and then all of this to the power of 2. Because since it was 1 minus sine x squared and all of that to the power of 2, now we're going to get 1 minus u squared and all of that to the power of 2, because everywhere we see sine x, we're going to replace with u. And now let's take this last term, cosine x dx, and then let's do it over here. So now we got cosine x dx. In scenario 1, to rewrite in terms of du, we had to solve for sine x dx, and in that scenario it was negative because the derivative of, what am I trying to say? Because the derivative of the cosine was negative sine, so there was a negative number there. So to rewrite in terms of du, we had to solve for something else. But this time it's a little easier because the derivative of sine is positive cosine. So the way it works out and the way all the math works out, it makes it such that it's already positive and du already comes as positive cosine x dx. So to rewrite in terms of du, we solve for cosine x dx, but we don't even have to do that because du already is cosine x dx. So that's pretty cool. That's pretty awesome. So anyway, let me stop babbling and just finish the problem. Anyway, so let's rewrite this cosine x dx in terms of du. So we have cosine x dx here, and since we established that du is equal, to cosine x dx, everywhere we see cosine x dx, we can instead put du. So since we already substituted all these terms, for sine x to the fourth, we got u to the fourth. For 1 minus sine x squared and all of that squared, we got 1 minus u squared and all of that squared. And for cosine x dx, we got du. Now let's rewrite the integral entirely. So now we're gonna have what is it? Okay, so we're gonna have u to the fourth times 1 minus u squared and all of that squared, and then du. So this is what we have when we rewrite the answer from step 4 in terms of u and du. So this is step 6. All right, let's go on to step 7. All right, so for step 7, we're going to multiply all the terms out, then we're going to rewrite the equation. So what we had before from step 6 is we had the integral of sine, from step 6 we already rewrote it in terms of u substitution. So what we had was u to the fourth times 1 minus u squared and all that squared du. So when I say multiply all the terms out, what I mean is we're going to multiply all of this, like all of this, we're going to multiply by each other, and by the end, we're going to have individual terms like plus and minus by each other and stuff like that. So let me take this integrand right here and rewrite it, okay? U to the fourth times 1 minus u to the second and all of that squared. We're going to multiply all this out. So let's start with this term right here. 1 minus u squared and all that squared is equal to 1 minus u squared times 1 minus u squared. Now, we can just FOIL this out. FOIL obviously stands for first, outer, inner, last, and stuff like that. So, yeah, so let's FOIL this out to, get the answer. So, 1 times 1, that's 1. 1 times negative u squared, that's negative u squared. Negative u squared times 1 is negative u squared, and then negative u squared times negative u squared is positive u to the fourth. Now we can combine like terms here, negative u squared minus u squared. The coefficients are obviously 1. Since there's no coefficients there, you can think of it as times 1. And then negative 1, well, the coefficients are negative 1 essentially because minus and minus, but, well, I'm sure you guys know what I mean, but negative, you can think of this as negative 1u squared minus 1u squared. That's basically what I'm trying to say. And negative 1u squared minus 1u squared is negative 2u squared. So we can rewrite this as 1 minus 2u squared plus u to the fourth. So let me rewrite that for. And then, so now we have established that 1 minus u squared and all of that squared is equal to 1 minus 2u squared plus u to the fourth. Now, in the integrand, we had 1 minus u squared and all that squared. We also had it times u to the fourth. So now let's multiply u to the fourth by this to multiply all the terms out and see what we get. So u to the fourth times 1 minus 2u squared plus u to the fourth. That is equal to, let's distribute it all out, u to the fourth minus negative 2u squared. You can multiply the bases. 1 times negative 2 is negative 2. Then u to the fourth times u to the second is u to the sixth. Remember rule number 1, do not do u to the eighth. I tutored so many people and they would always get that wrong. It's u to the sixth because it's a term with an exponent times a term with an exponent. If you're timesing two terms with the same base, you add the exponents. So it's negative 2u to the sixth, and then u to the fourth times u to the fourth is u to the eighth. So basically what we have, like when we multiply all the terms out, we have u to the fourth minus 2u to the sixth plus u to the eighth. That's what this equals when it's all multiplied out. So now we've established that u to the fourth minus 2u to the sixth plus u to the eighth, this right here is equal to the integrand. So since this is equal to the integrand right here, we can rewrite the entire integral as u to the fourth minus 2u to the sixth plus u to the eighth du. Alrighty, and so for step 8, let's go to step 8. Let me just rewrite my notes. So for step 8, we're going to solve the integral of the answer we just got from the previous step. I took the liberty of already writing it. The answer is the integral of u to the fourth minus 2u to the sixth plus u to the eighth du. So essentially, let's just solve this integral. The answer would be u to the fifth over 5 minus 2u to the seventh over 7 plus u to the ninth over 9 plus c. Alright, so then that's the answer. So let's go to step 9. Alrighty, so for step 9, what we're going to do is we're going to take the answer we got from step 8 and we're going to replace u with the trig function we substituted with the trig function that we substituted with before. So basically this step is we just replace u with sine x. So what we had, the answer we got from step 8 was u to the fifth over 5 minus 2u to the seventh over 7 plus u to the ninth over 9 plus c. So we already established that u is equal to sine x. So now everywhere that we see u, we're going to replace that back with sine x. And basically that'll be our answer. That's pretty much our answer. Once we replace it, we're pretty much done, and that's our answer. So let's replace it. So for u to the fifth over 5, we would get sine x to the fifth over 5. Minus 2u to the seventh over 7 would be minus 2u. Minus 2 sine, minus 2 sine x to the seventh over 7 plus And then u to the 9th over 9 would be sine x to the 9th over 9 and then plus c. So then this is the answer to the integral. Please ignore this. I'm gonna put some whiteout on that before I upload this to the notes on Google Drive. But this is basically our answer right here. This is our answer to the integral. And I always like to start finish things up with a conclusion. So from the conclusion, what we had originally, we can conclude that originally, so we had the integral of sine x to the 4th times cosine x to the 5th and a dx, of course, and we can conclude that that equals sine x to the 5th over 5 minus 2 sine x to the 7th over 7 plus sine x to the 9th over 9 plus c. That's the answer to the integral. Oops, somebody's calling me. Just a second. So I just kind of realized, like, in the last episode, I kind of, like, my pen kind of, like, blocked the plus c. So I just want to kind of show off the conclusion again. The conclusion is that the answer to this integral right here is this. The answer to the integral of sine x to the 4th plus cosine x to the 5th dx is equal to sine x to the 5th over 5 minus 2 sine x to the 7th over 7 plus sine x to the 9th over 9 plus c. So that's the answer right there. I also have a second example as well that's also available. I already solved all the steps for it, and I'm also going to upload this with the Google Drive document that will be available in the description link as well. This is a scenario of sine x to the 6th power times cosine x to the 3rd power. As you can see, m, which is the exponent of the sine function, is 6, which is even, and n, which is the exponent of the cosine function, is 3, which is odd. So that's scenario 2, where m is even and n is odd. It's a second example. It's available in the description link as well if you just want to look through it and see how I solved it as well. That's a second example for you guys. So that pretty much sums up this topic, and I will see you guys in the next video. Thank you.
I could cry, fall.